Welcome to the AI Checkpoints. Before we dive in, just a quick disclaimer. This content is generated by AI. Okay, so today we're embarking on, well, a really fascinating deep dive. We're looking at a new reasoning system that's kind of challenging some fundamental assumptions about AI. It's called K2-Think. Imagine getting, cutting-edge AI performance, but without the monumental size we've sort of come to expect. Our mission today. To unpack exactly how a relatively small model is achieving frontier performance, it really makes us reconsider that idea that bigger is always better in large language models.
It's truly remarkable, the approach taken by the Institute of Foundation Models at Mohammed bin Zayed University of Artificial Intelligence, MBZUAI, because, we're used to seeing models like GPT-5, Gemini 2.5, just scaling up and up, billions, even trillions of parameters. But K2-Think, it demonstrates that strategic post-training, some smart inference time enhancements, these can let a 32 billion parameter model genuinely rival systems that are orders of magnitude larger. It's a pretty significant shift, and they detail it in their report. K2-Think, a parameter-efficient reasoning system.
Yeah, let's unpack that because the headline is definitely compelling. K2-Think, only 32 billion parameters, and it's matching or even beating much bigger models. They specifically call out giants like GPT-OSS 120B and DeepSeek v3.1. So how do they achieve this incredible parameter efficiency? What's the secret sauce?
Yeah, the researchers at MBZUAI, they've developed what they call an integrative post-train recipe. Think of it like a highly optimized pipeline, maybe, built on 6 key technical pillars.
6 pillars, okay.
Right. So at a high level, they first supercharged the model's initial training, made it think step by step for complex problems. Then they added a sort of built-in quality control system to verify its own answers.
Oh, interesting.
And on top of that, they optimized how it actually plans and delivers those answers during use. They even leveraged some cutting-edge inference-optimized hardware. It's really the synergistic combination, not just one magic bullet. That makes the difference. And importantly, it's all using publicly available open-source data sets.
Okay, so what does this all mean for you, the listener? Well, it means we could be looking at a system that makes advanced AI way more accessible, maybe more affordable too. Imagine top-tier reasoning capabilities without those exorbitant costs and massive computational demands we usually associate with the biggest models. And the best part? K2-Think is actually freely available. You can go explore it yourself at k2think.ai.
Indeed. And this capability, it raises a really important question for the whole field. Can we genuinely achieve top-tier reasoning without that huge compute and financial investment? K2-Think seems to offer a compelling yes. It particularly excels in mathematical reasoning. That's where it achieves state-of-the-art scores for open-source models, beating many larger competitors.
Wow.
But importantly, it's not a one-trick pony. It also holds up really well in code and science domains. Their findings clearly show its superior parameter efficiency. You get more bang for your buck, basically.
Let's dive into the how then. This development process, it involved distinct phases, right? Starting with phase 1, supervised fine-tuning, or SFT. For those maybe not deep in the weeds, what exactly is SFT and why was it so crucial here?
Right. Supervised fine-tuning, SFT, it's really the foundational stage. It's where you teach the model specialized skills. In this case, they started with the Qwen 2.5 322B base model. Now, this model wasn't initially tuned specifically for complex reasoning.
Okay.
So through SFT, they guided it. They used a really meticulously curated data set called AM Thinking V1 Distilled. And this data set wasn't just, facts. It was rich with long chain of thought reasoning traces.
Like showing its work.
It's exactly showing its work. Plus, instruction response pairs, prompts across math, code, science, even general chat. The goal was to teach the model to generate these structured, step-by-step responses, make its reasoning process transparent before it gives the final answer. And the data from their report, it showed that performance, especially on tough math benchmarks like AIM 2024 and 2025, it improved rapidly, really fast, within the first third of this training phase. Scores for AIM 2024 stabilized around a very impressive 79.3% pass at 1.
Okay, now here's where, for me, it gets really interesting. After SFT phase 2, reinforcement learning with verifiable rewards, RLVR, that phrase, verifiable rewards, really caught my attention. Can you explain what that means? And how did this build on that SFT foundation?
Yeah, RLVR is fascinating. It tackles one of the biggest challenges in AI alignment, right? How do you truly ensure the model generates correct, reliable outputs? So instead of just relying on subjective human feedback, which can be slow, maybe inconsistent, they essentially gave the model an objective correctness checker. For a problem, for instance, the answer is either right or wrong. It's verifiable.
Makes sense.
They use this data set called Guru, nearly 92,000 verifiable prompts across lots of domains. Math, code, science, logic, simulation, even tabular tasks. Now, RL consistently improved performance, but what the report highlighted was pretty key. Starting RL from an already strong SFT checkpoint gave better overall performance compared to just training RL straight from the base model.
Ah, so the order matters.
Exactly. It tells us that SFT teaches the model how to reason, and then RLVR fine-tunes it to make sure that reasoning leads to consistently correct answers. It locks in the quality.
Okay, so you've trained it to be smart, rewarded it for being correct. What's next? Phase 3, test time improvement. This sounds like optimizing it for when it's actually solving problems for someone. What techniques do they use here?
Precisely. This phase is all about making the model smarter as it's answering you, adding layers of deliberation, you could say. It involved two main techniques. First, agentic planning before reasoning. They have a great name for it. Plan before you think.
Huh, I like that.
Yeah. Imagine you're tackling a complex project. You don't just dive in, right? You make an outline, break it down first.
Sure.
K2-Think is taught to do something similar. A user query first goes to a planning component, basically an external model that generates a high-level plan or identifies key concepts. This augmented, sort of pre-planned prompt then goes to K2-Think.
Okay, so it gets a roadmap first.
Kind of, yeah. And the second technique is test time scaling using best of n sampling. Once K2-Think has that augmented prompt, it generates multiple responses. Let's say 3, n equals 3 in their case.
Right.
Then finally, an independent LLM acts like a judge. It performs a pairwise comparison to pick the single best response to give back to the user.
Wow, that's a really holistic approach. It's not just about raw intelligence, but about being deliberate, efficient, and well-judged in how it gets to the answer, which for you, the listener, that really matters for actually using this thing day to day.
Absolutely. And beyond these, sophisticated training and test time strategies, the actual deployment of K2-Think is pretty remarkable too. It completes the picture for real-world use. They're deploying this system using something called the Cerebras wafer scale engine, the WSE.
Ah, yes, the WSE.
Right, combined with speculative decoding. This is that final crucial pillar.
Yeah.
For those unfamiliar, the Cerebras WSE is essentially the world's largest chip. It's purpose-built for AI, massive parallel processing power.
Okay.
Deploying K2-Think on these systems, it enables unprecedented inference speeds. Their report states it delivers about 2,000 tokens per second.
2,000 tokens a second, that's fast.
It's incredibly fast. It's a staggering 10 times improvement over typical high-end GPUs like the NVIDIA H100. So think about a complex reasoning task, maybe generating a 32,000 token response.
Yeah.
On the WSE, that takes just 16 seconds. On an H100, nearly 3 minutes.
Whoa. 16 seconds versus 3 minutes?
Exactly. That difference, it dramatically transforms the user experience. It's not batch processing anymore. It's genuinely interactive reasoning.
That's a huge practical difference. Minutes versus seconds. Yeah, that changes everything in terms of usability. But okay, let's talk results. The proof in the pudding. K2-Think's actual evaluation scores. Where does it really shine?
Well, it truly excels in competition-level math questions. These are notoriously difficult for AI. Their evaluation shows a really impressive micro-average score of 67.99 across all math questions.
67.99. How does that compare?
To put that in perspective, it significantly outperforms models like GPT-OSS-20B, which scored 52.5. And it even beats larger open-source models like DeepSeek v3.1671b, which came in at 64.43.
So it's beating models much larger than itself.
On math, yes. It's especially strong on really challenging benchmarks like OmniMath Hard. Got a score of 60.73 there. That puts it right at the top of all open source models for math reasoning.
Incredible.
And furthermore, it shows remarkable versatility. It's not just math. Across science and coding domains, too. Scored 63.97 on LiveCodeBench, 71.08 on GPQA Diamond. It shows it's not just a specialist. It's a highly capable generalist in these complex reasoning tasks.
And remember those test time improvements we talked about, the plan before you think and the best of n sampling. The report shows these gave significant gains, right? Like 4 to 6 percentage points improvement across math benchmarks.
That's right. Table 2 shows that clearly.
But here's the kicker for me, what's truly surprising. Plan before you think also reduced the length of the responses. According to their table 3, outputs were nearly 12% shorter in some cases. So you get higher quality and more concise answers. Quality up, tokens down. That's the dream.
It's a critical takeaway, especially for real-world application. It means the model isn't just more accurate, it's clearer, more concise. It really challenges that notion that complex reasoning always needs these long, verbose outputs. This level of efficiency is just crucial for making sophisticated AI reasoning both powerful and practical. Saves compute, saves time, still delivers top results.
Okay, but anytime we talk about advanced AI being widely deployed, especially openly, safety is absolutely paramount. The K2-Think team did extensive red teaming. What did they find about its safety profile?
Yeah, ensuring safe operation is non-negotiable for an open release like this. You have to do your homework. The researchers systematically evaluated K2-Think against adversarial prompts, harmful content, robustness stress tests using established public safety benchmarks. They consolidated their findings into 4 key areas: high-risk content refusal, conversational robustness, cybersecurity and data protection, and jailbreak resistance. Gives a pretty comprehensive picture of operational safety.
And how did K2-Think actually stack up in those areas?
It demonstrated strong performance in refusing high-risk content, got a macro average score of 0.83 there, and it maintained consistent safe behavior in multi-turn dialogue, scoring 0.89. So, good conversational safety.
Okay, that sounds promising.
It is. However, the researchers were also commendably transparent about areas needing improvement. They noted some susceptibility, particularly in cybersecurity and data protection, scored 0.56 there, and jailbreak resistance, 0.72.
Okay. What does that mean practically?
It indicates some potential, for example, for revealing system prompts under certain attacks, or perhaps aiding in cyber attacks if misused. But they openly state that addressing these specific areas is an active priority in their roadmap.
That's good to hear. Transparency is key.
Absolutely. It's crucial for building and fostering trustworthy AI in the community. You have to acknowledge the limitations.
So if we zoom out and look at K2-Think's entire journey, development, deployment, safety, what does this tell us about the future of AI development, especially for open source models and, their accessibility?
I think if you connect this to the bigger picture, K2-Think really sets a new precedent for open science and AI. They didn't just release the model weights or the training artifacts, they deployed a full reasoning system for public use through an API, through a web portal at K2Think.ai.
Right, you mentioned that.
By doing that, they're essentially inviting the entire community to battle test this public-facing LLM infrastructure. This allows everyone to learn best practices for hosting, for stress testing, for improving these models under real-world conditions. It's a really significant step towards democratizing access to these frontier AI capabilities.
Yeah, it really highlights that joy of discovery, doesn't it? It demonstrates that innovation in AI isn't solely about brute force scaling or who has the biggest supercomputer. It's also, critically, about clever engineering, about thoughtful integration of different techniques, and a commitment to open science. It's about making advanced AI work smarter, not just bigger, for everyone.
This deep dive into K2-Think, it truly shows us that parameter efficiency and strategic computation, these are incredibly powerful paths forward. They're avenues for achieving frontier performance in AI reasoning, making advanced capabilities more accessible and, crucially, more sustainable.
Absolutely. The K2-Think system makes a really compelling argument that smaller models can indeed punch above their weight, given the right recipe. And it leaves us with, well, a provocative thought, maybe. If sophisticated reasoning can be achieved with more modest resources, what does this truly mean for the global landscape of AI innovation? And maybe more importantly, who gets to participate in shaping its future? That's it for this deep dive. Thank you so much for joining us. Hit like and subscribe if you like the content. See you next time.